So we're going to explore this reaction where we're converting ozone into oxygen. So our first set of reactions in this mechanism converts O3 into O2 plus O. And that one's considered fast with two different rate constants. The forward rate constant is K1 and the reverse rate constant is K negative 1. The second reaction, which is fast, it converts O3 and oxygen into two O2 molecules with a rate constant of K2. So you notice that the first one is fast and the second one is slow. So the first question says, on the basis of this mechanism, write the rate equation for this reaction. So we do have some work to do because when I go to start writing my rate expression is going to be something like V equals, and remember my rate expression is going to depend on my slow reaction. So it'll be K2 and then times my reactants, which in this case are going to be O3 to the first power and O to the first power. But notice that I have a balanced equation that does not include the intermediate O. So I cannot keep O in this reaction. So what I'm going to do is I'm going to make a new set of rate expressions that involves O. So now I see that O is in my fast reaction and also in my slow reaction. So I'm going to be able to have two different expressions that will involve O. So since I already took care of my slow one, I'm going to be able to use my fast reaction. So let's write that out. So that means that if I write, first let's just write the reaction that's going on. So the first one that involves O has a rate constant of K1. So when I go to write the rate law for that one, it'll be K1 times my starting material, which is O3, and then I'm done with that one. So notice that I also have a reverse reaction for that one. So let's write that one out. Let's write it as if it was a forward reaction. So that'll be, so my rate law for that one is going to be K minus 1 times my reactants of O2 and O. And all of these are equal to each other. So K1 times O3 equals K minus 1 times O2 times O. So that's good. Here's my O, my concentration of O, so I can go and solve for that. So if I solve for the concentration of O, just take everything and put it on the other side. So my K1 and my O3 are still on the left. And now my K minus 1 and my O2 are there also. So just take these to the other side. So now I can plug this back into the rate expression I had at the beginning. So I had V equals K2 times O3 times O. And now I can get rid of just my O. And I can go plug in my value of O, which is K1 times O3 over K minus 1 times O2. And let's do a little combining. So I'm going to get, I can combine my O3s, will be O3 squared. So my rate constants will be K1 times K2 over K minus 1 times O3 squared over O2. So this has allowed us to take into consideration the fact that this reaction is going on as a two-step process, and it has an intermediate that gets used up in the second reaction. And so we need to reflect the fact that O does not appear in the overall balanced equation, but does appear as part of the rate equation. So my final answer for the rate expression for the reaction up above is that it is K2 times K1 over K minus 1 times O3 squared divided by O2.